So it's time for starting the program, right?
Yeah, just a minute, Doctor. Can you hear me?
Is it time for starting the program?
Hello, Doctor. Can you hear me?
Yes, of course I can hear you. Can't you hear me?
Yeah, I can hear you. So just a minute for the introduction, if it's possible.
Okay, that's fine.
Yeah. السلام عليكم ورحمة الله وبركاته. أسعد الله مساكم بكل خير وحياكم الله في هذه الورشة بعنوان Introduction to Edge Computing مع الدكتور ثافصل. دكتور ثافصل أستاذ مساعد بقسم الهندسة الكهربائية كلية هندسة جامعة الملك خالد. وطبعا دكتور ثافصل متخصص في هندسة الاتصالات، ومن هذا المنطلق شفنا أنه أكثر شخص كفء وعنده القدرة لإعطاء محاضرة في مجال جديد نامي مثل الإدج كومبيوتنج هو الدكتور ثافصل. فإن شاء الله موعودين بمعلومات جديدة ومثرية في مجال نامي ويشكل معالم المستقبل التقني بمشيئة الله. طبعا هذه الورشة بإدارة فرعي تريبولي بجامعة الملك خالد والWIEE بجامعة الملك فيصل. وفي نقطتين حاب أنوه عليهم. الأولى هو أنه سيتم نشر رابط التحضير لنهاية المحاضرة في الشات إن شاء الله. فإحنا نبغى لكم الفائدة، أهم شيء التركيز بالمحاضرة. والشيء الثاني هو بحالة وجود أسئلة أو استفسارات أيا كان فراح نعطيكم مجال بنهاية المحاضرة للنقاش مع دكتور ثابت إن شاء الله. So thank you so much, Dr. Thafasalijyas, for your comments in conducting such an enriching presentation in a new developing field. Yeah, and actually it's not really necessary to restate the introduction in Arabic because Dr. Thafasalijyas is able to understand and speak Arabic as well. Is it right, Doctor?
Yes,
Yeah.
of course. To an extent, I can understand. Anyway,
Yeah.
thank you for your very flattering introduction.
Yeah, thank you so much. And if you have any difficulties, technical issues or something, just text me on my WhatsApp, Doctor, if it's possible.
Of course. I am very fine now currently.
Yeah.
So shall we start discussing about this
Yeah.
particular thing, right?
Yeah, go ahead. Thank you.
Okay, then, dear friends, Assalamu alaikum wa rahmatullah. Actually, I'm very much privileged to be here along with you all, discussing about some of the state-of-the-art technologies in computer-based communication, internet and all. And today, we are going to talk something very general and introductory about what is edge computing. It's a very important paradigm of communication that's going to have a lot of breakthroughs in the coming years. It's going to change the way that we are communicating, making decisions, using information technology in our lives and so on. So here we have a lot of people connected together through internet, through a computer network, right? A worldwide computer network. We are all connected here together, and we have very intelligent people out there at the edges of this network. Quite a lot of people. We are having now 41 participants. Many of them are quite intelligent people. And many of us are able to take and make a lot of important decisions in our lives. I suppose you can all hear me clearly, right? Any issue?
Yes, Doctor, your sound is clear.
Yes, thank you. And so we have, you see, when we think about the particular network now we are having for this particular talk on introduction to edge computing, we know all of us are connected to the network through various devices. Maybe some of us may be connected through computers, laptops, mobile phones, maybe iPads and the tablet devices, right? And we are all people who can use our intelligence. We can make a lot of important decisions in our lives, right? So I will try to motivate the particular idea of edge computing in the beginning. See, when the internet was when somebody is talking and okay, see, when the internet was launched for the first time, actually it was something like a client server architecture. Like you have a lot of computers and we have users are there, they are having their own computers, which you can call as clients. Then you have servers also. So we want to establish a communication between two computers, right? So that was the purpose of having an internet system. Why we want to have a connection between two computers is because suppose I want to get some particular task done. I will send my data to another server computer, and that particular computer may be having the power and the resources to address the particular services that I need from it. And it will do the processing on the data, and after that it will send back the results to me, right? So actually, when internet was formed, actually the primary focus was to establish communication between computers. But later on, what actually happened was, when the thing developed, actually, along with communication, along with communication, along with communication, along with communication, actually, what actually was needed is there were a lot of computing actually was also became part of the network. Actually, it was not just communicating between different computers. A lot of computers will be joined together to provide cloud services, various services. For example, I want to get something done, and I may send a request, and maybe there is a cloud serving platform. They will be having a lot of computers together, which we can call it as a data center. And whatever request that I am sending to them, they will be using a lot of the computers, many distributed computers, and they will be doing processing. So a lot of very complex, highly data intensive processing, everything could be done using the cloud services. Just what you can just imagine, that there is a communication, along with there is a decision making, a lot of intelligence, artificial intelligence, a lot of programming, analysis, right? Like that, you can have a lot of things incorporated into the network. So actually, people were thinking about services. We want to get a lot of services done using the internet. It was not just a single computer that is serving us. Maybe it is a distributed network of many computers together serving my need, just like it is serving the needs of many people, maybe many corporations, companies, businesses, and on so on. So this was how actually things developed. So that is how the cloud computing paradigm emerged somewhere in the 1990s and all. You can think about cloud computing. It emerged. And when cloud computing emerged, a lot of cloud computing services are IBM is having their own service, Amazon is having, Microsoft is having their own services. Cloud services are provided by a lot of big companies. So when in a cloud computing paradigm, what actually is being done is, suppose if I am having some processing need, some data processing need, what I am going to do is I will subscribe to the services of a particular cloud provider like Amazon, for example. And I will send them my data, and they will do a lot of complex processing on the data. And from that, they will do a lot of decision making. And those decisions, the analysis, the processed data, everything will be sent back to me by the cloud service provider. So here, there is one very important problem. The challenge is the network should be having a very high bandwidth. That is, I am sending quite a lot of data to the cloud service providers. And after processing, they are also sending back a lot of processed data along with many other potpourri back to me through the same network. So that means we should have a reliable, very high bandwidth network. Of course, if the data produced by the users are very less, this is not an issue. Cloud service is fine for us. So, but what actually happened was, later on, the amount of data produced by the various users started increasing exponentially, if we can call it. Like, for example, nowadays, we have a lot of things connected to the internet. We have mobile phones, we have laptops, we have a lot of cameras, closed circuit TV cameras. For example, if you want to monitor your workplace or maybe your home from a very remote place, right? You might have installed closed circuit TVs, cameras, and all those stuff at your workplace or residence. And this particular thing is producing data every second, maybe several MBs or sometimes even several GBs of data. If the required resolution of video and all is very high, a lot of data will be produced. So you can see that nowadays we are having a lot of edge devices. You can call them edge devices like cameras and so on. Sensors are there, mobile phones are there. And all these things are producing quite a lot of data. And the projection is by 2025, around 175 zettabytes. 1 zettabyte is around 10 raised to 21 bytes. That is a huge amount. Very, very huge, very big amount. Around 175 zettabytes of data will be produced by the edge devices or the devices that are connected at the edge of the network. And why do we produce all this data? We want to process this data. We want to analyze this data. And from the analysis, we have to come to some certain conclusions. We have to make a lot of decisions, right? And the decisions have to be implemented. For example, I will tell you a very simple case. For example, if I am having a home automation system, right? Suppose the temperature, there is a temperature sensor in a particular room. The temperature sensor is continuously monitoring the temperature in the room. I'm giving a very simple example. And this particular temperature data, actually, based on the temperature data, I have to control the air conditioner in the particular room or hall, whatever it is. So what I'm doing is, it's a very simplistic example, but still, it's just to motivate the particular idea. So what I'm telling is, I'm sending the temperature data from the temperature sensor. Maybe it is connected to an Arduino microcontroller, maybe Raspberry Pi, whatever it is. It is connected to a microcontroller. For example, let us think that the microcontroller is not running any program. For the sake of understanding, that's all. In actuality, it is not like that. The microcontroller may be connected to the internet through some ESP device or something like that. And it will be sending the data through the internet to a cloud service provider. It will be analyzing the temperature data. Based on the analysis, it will make a decision whether the air conditioner has to be turned on or turned off, or maybe the temperature setting of the air conditioner has to be changed, right? So here there is data produced by the temperature sensor. This data is transmitted through the internet. It is reaching the cloud service provider, and the cloud service provider is analyzing the data. And based on the analysis, actually, it is making a decision. And that particular decision is conveyed back to the temperature regulator or controller of the air conditioner in your room. It's a very simple example I'm telling. So you see, you have to send a lot of data through the internet, and the decision has to come back again as a data or information through the internet. So that means you have to transmit data and you have to receive back the data. The time delay between the transmission and the reception of the relevant result is called latency. That is what you mean by latency. So if this is a very simple example. Suppose if you are having a lot of sensors, you are having a lot of video cameras, a lot of devices are there, then the amount of or the volume of data that you are going to send is going to increase by leaps and bounds, right? So that means the latency may increase like anything. You cannot predict how much time it will take for the data to be transmitted and the decisions that we have to implement to be received back, right? So this is a question of latency, and latency in an internet or a computer network is not very predictable. You can have only statistical characterization. You will have to use a lot of probability, statistical tools to predict what is the average delay, the average latency, and so on. So this may not be very suitable. For example, when you have to take immediate decisions. For example, in an industrial workplace, when you cannot have a delay in making decisions. From the data that you have actually gathered using the sensors and other devices, monitoring devices, you will have to instantaneously make a decision and implement the decision. If you are not doing like that, what actually is going to happen is it may lead to a lot of dangerous situations, especially in an industrial plant, or maybe in an emergency critical care unit in a hospital, and so on. The decision making cannot be done by a remote server. The decision making has to be done at the place where the data is generated. And this particular place is called the edge, the end point in the network where you are actually generating the data and where you are actually implementing the decisions based on the data generated. Because we are generating data just because we want to analyze the data, we want to make decisions and also on, right? And we have to implement those decisions. So you cannot actually trust or rely on the particular internet or the cloud network for doing this thing, especially when the services that are needed are critical and has to be implemented in a very rapid fashion. So in this case, actually what we need edge computing. Edge computing means at the edges or very nearby to the edges where the data is generated, you should have computing facilities that will analyze the data and that will make intelligent decisions and that will help to implement the decisions very fast at the edge itself. You don't have to use centralized servers that are part of the whole internet network. You don't have to send it through a long distance and get back the results from a remote server. So this thing may not be practical in such cases, especially when the edge devices are increasing exponentially. There are billions of devices connected to the internet now. Because everything is going intelligent now. The air conditioners that you are using, the refrigerators that are using, all the home devices, all the equipment that are being used in hospitals and healthcare systems, and in the industries, all the monitoring devices, the sensors, the various actuators, all the things that are used in industrial plants, maybe in electrical power plants, everywhere. The number of sensors and edge devices that are connected to the network are increasing exponentially, and there are billions and billions of devices connected, and all these devices are generating a huge amount of data, and the network is incapable of transmitting all this data to certain centralized servers and process them and send back the receivers. So quite a lot of the computing that are done in the central servers and data centers have to be transferred back to the edge systems itself. So we should have computing facilities. We should have edge servers, which can do a lot of processing, which can make a lot of very intelligent decisions, so that only very essential data need to be sent to the central servers in the internet. So this is the basic idea of edge computing. You can see here, for example, in this particular diagram, you see we have a lot of sensors here. There is a light sensor here. Maybe there are other sensors. Maybe this is a temperature sensor, whatever it is. A lot of actuators. The difference between a sensor and actuator, sensor is it senses some particular parameter like a temperature or pressure or the light intensity, or maybe the pulse of a patient in a hospital, or maybe the blood pressure of the patient, or maybe the ECG, electrocardiogram, ECG signals. Like that, there are quite a lot of sensors that sense various physical signals, right, and physical parameters. And actuators are the things which will do something according to an input. For example, you can have a stepper motor that will turn something, maybe a robotic arm. So it's an actuator. So that's the difference. So actuator actually receives some data and does something. And the sensor is it will be actually monitoring the physical surrounding, and from that it will be taking some data and sending it to the computing devices. So you have a lot of sensors here, and these sensors are connected to certain edge devices. Edge devices, you may have something like an Arduino board, maybe a Raspberry Pi, or maybe a laptop or a tab or something, whatever it is. And all these things can do some processing at the edge itself, right? And based on that, it can run certain programs, it can process the data. And based on the processing of the data, it can take certain decisions. Based on the decisions, it will drive the actuators to do certain things. So this is a very simplistic picture of this particular thing. And Now we are having switches here, gateways and switches and everything that is connecting the edge devices and edge sensors and other things, edge servers and all, to the wider internet where you are having the cloud services. So only when you are when it is necessary to store the data for a longer duration, and whenever you want to have a very slow processing of the data, you will be sending those things to the cloud service. Otherwise, immediate decisions are to be taken at the edge servers and the edge devices itself. So this is the basic paradigm of an edge computing system. So I suppose that you have an understanding why we go for edge computing rather than cloud computing. So we are now actually living in something called a post-cloud era. Of course, cloud services are there, and we may be needing a lot of cloud service. For example, we are having cloud services. All the social media platforms that we are using, all are making use of cloud services, YouTube, or whether it is Snapchat or Facebook or WhatsApp, whatever it is, they are all using cloud services. But we need to make a lot of immediate decisions in a lot of very critically important areas related to healthcare, maybe industrial plants, maybe home automation, and so on. So we have to think about edge computing. So this is the basic idea of edge computing. And here you can see a cloud computing platform. Here you see we are having the client computers. And what we are doing, we are not doing anything here. We are sending all the data through internet to certain data centers where we are having a lot of servers and maybe other distributor servers also. The difference between a data center and a distributor server is, in a data center, you are having a lot of servers configured together to provide a lot of different types of services. And distributor servers need not be in a particular physical location like a data center. It may be distributed through a very large geographical area. Ultimately, whether it be data centers or distributor servers, you are having a servers, and the servers will be delivering certain services. They will be running certain programs and delivering certain services to satisfy the needs of the client computers. So you can see that all the programming, decision making, all the services that are being required by the client computers are taken up by the data centers and the distributed servers. So this is a remote paradigm. Like the client computers are remotely connected to data centers. For example, sometimes you may be having a client computer and your server may be located in the United States or UK or maybe some other country. So that happens. So when this is a situation, there is the problem of latency. You have to transmit the data from your computer to the data center or server, and you receive it back. And the time between the transmission and the reception of the output is called the latency. So this is a big problem, right? So if you think about the differences between edge computing and cloud computing, the one aspect is the location of processing of data. Processing means you're running certain programs, you're processing the data, you're gathering intelligence from the data, and you are making a lot of intelligent decisions from the data. And using those intelligent decisions, you're doing something at the particular place where you're gathering the data. That's it. As I have mentioned earlier about the air conditioner and temperature sensor example, right? So in edge computing, this processing is done closer to the data source. You have edge servers. You don't have remote servers or cloud servers. You have edge servers which are very close to the data source at the edge itself. So what in cloud computing, what you're doing is the processing is done in centralized data centers, usually located remotely from the data source. That's the difference of the location of processing. And of course, we have talked about the latency, the time delays. And when you're going for edge computing, the latency is very low because the processing is done very close to the data sources itself, where you need the to make the decisions and all. So this is more suitable for real-time applications. And real-time applications are very crucial in hospitals, healthcare systems, critical care units, industrial plants, home automation and all. Real-time, they are all real-time applications. That is, when you have to monitor the situation and you have to take immediate action. You have to make immediate decisions and take immediate actions. That is what you mean by real-time applications, right? So whenever you can imagine, you can think about a real-time application, like whenever you're talking with another fellow on a video chat. See, this is a real-time application, like even though it is not a edge computing paradigm, like actually you want to see how the you want to see the person face to face, maybe through your mobile phone or maybe computer, and the communication should be in real time, right? It cannot have a delay. That's what I mean by real time. But in cloud computing, it may experience higher latency due to transmission to and from the distant data servers. And another difference between edge computing and cloud computing is in the bandwidth used. You see, bandwidth is the how much frequency spectrum of the channel that or the connection or the network that you are using, right? So suppose if you are in edge computing, you are only sending in the ultimately necessary data to the remote servers, right? Whatever data is actually needed to be sent to the remote servers, that only you will be sending through the internet. All of the data will be processed at the edges itself. So there is optimal utilization of the bandwidth in edge computing, right? But in cloud computing, what you are doing, whatever data you are generating at the edges, all the data has to be transmitted through the network to the remote servers, right? The remote centralized server. So that means the bandwidth usage will be more. So that means there is no optimal usage of bandwidth in cloud computing. So this is an advantage of edge computing over cloud computing. Another thing is called scalability. In terms of scalability, actually, cloud computing is better than edge computing, because in cloud computing, you can configure quite a lot of servers to deliver a lot of very powerful services. But in edge computing, to the edge devices, you can configure only fewer number of edge servers, and that also with lesser processing power and capabilities, lesser data storage capabilities and all. So in terms of scalability, you can say that cloud computing is far better than edge computing. The scalability of cloud computing systems are higher compared to the edge computing systems. Suppose you understand the idea of scalability. That is, you have a lot of physical computer resources. You want to configure all of them together to provide a lot of different services, right? But in a cloud computing platform, actually, you can have a lot of distant servers, and those servers all will be very powerful, and you will be having quite a lot of servers, and all of them can be configured together using various technologies like virtualization and many other stuff, so that a lot of powerful applications can be done. That much power and scalability may not be available at the edge devices. And in terms of reliability, of course, edge computing is far reliable than cloud computing. Why? Because you don't have to send the data through a network, and you don't know at what time it will be reaching the cloud servers and what time it will be processed by the cloud servers and received back. So there is no definite measure of reliability that you can have. Maybe some statistical measures are possible in cloud computing. But in edge computing, actually, you are not using the centralized cloud infrastructure of the network, right? You're doing the processing at the edges itself. So it's more reliable. You're having a direct connection of your edge devices to the edge server. So it's going to be more reliable when you're going for edge computing. So you can see here the difference between cloud computing and edge computing. And the difference, you can see that the computation in a cloud network or a cloud computing architecture, you can see it is done in a centralized server system. And here, all the devices, maybe your camera, your car, the traffic signal thing, or whatever it is, everything is connected to an edge server. You're not going into the internet and the centralized server. These edge servers are directly connected to the edge devices, and a lot of processing is done at the edge server itself. So you can understand the basic difference from this particular diagram. Now, we will see what are the various components of an edge computing system. See, we have something called edge devices. You can see the thing here. You are having the edge device, the edge things. You are having scanners, sensors, maybe beacon lights. You are having other IoT devices. Those things can be connected to something like edge devices, which may be able to do some processing or maybe able to aggregate the data. It will be able to collect all the data together, and all those edge devices are there. and you can have near field communication connection, NFC communication or Bluetooth connection or whatever it is possible. Very adjacent devices. You can have a lot of communication systems. You can have such connections. Then they are connected to the edge data centers. And the edge data centers, you may be having edge servers and all. And here you can do the processing. After that, only the internet is coming. You see here. And it is the cloud data centers are beyond the networking, switches and gateways and all those stuff, right? So this is a particular architecture. So you can think about edge devices. Edge devices are the sensors that you are using, the actuators using, the smartphones, the IoT devices, and all these things generate a lot of data, right? Some examples are given here, like temperature sensors and all. And then you have the edge servers, which will be doing the intermediate computing nodes. A lot of computation and a lot of data analysis, decision making, everything will be done by the edge servers. Edge servers are computers, basically. You can have edge servers as your laptops. Maybe desktop computers can be used as edge servers. Maybe Raspberry Pi can be used as an edge server. Maybe Arduino itself can be used as a not a very highly powerful, less powerful edge server. Like it can run a program, it can analyze the data, it can produce certain results from the data, it can make some decisions based on the data. All these things can be done by the edge servers. Then you have the gateways, the routers, the switches, and all those stuff that will be connecting the edge servers to the internet or the cloud servers and all, right? So these things are the basic parts. Then you have the cloud or data center, which is actually only when you have to store a lot of data, and you can go for long-term storage of the data. And if you want to do some analysis, which may take quite a lot of time, you are not making a very what you can say, you are not making an immediate decision, a long-term projection. For example, in a company, the company is having a lot of data. All the data has to be analyzed thoroughly, and the company has to make a lot of decisions, long-term decisions on its business activities the following year, or maybe the following year, or maybe the following decade, and all those things. So this means slow analysis, slow and thorough, rigorous analysis, and that is not immediate decision making. So one thing that we have to understand about edge computing is not for long-term predictions, long-term decision making, long-term implementation of certain decisions in a workplace or a company or whatever it is. Actually, it's more related to immediate decision making, edge computing. Okay. Then you have to manage the various resource edge devices and the edge servers and all those things. For that, you may have edge management software protocols and all. Right. Now, this is the architecture for those things. And if you go for the applications, you can have IoT applications, are the autonomous vehicles that don't need a driver. The sensors will be actually determining the direction, the current direction, the current position, the geographical position. And a lot of things will be actually the data will be generated by the autonomous vehicle. Based on that, you have to make decisions on how to drive the car further. Then you have smart cities are there, healthcare systems are there, industrial automation is there. In all these areas, you can make use of edge computing. Here we have a IoT smart home application using edge computing. You see, you are having a lot of a smart home. There you may have a thermostat, right? You have a photoresistor, which actually it will be measuring the intensity of the lighting in the room, illumination in the room, motion sensor to detect whether somebody is moving. Fingerprints have to be detected, water levels, maybe there's camera, flame detection is there, gas leakage detection is there. A lot of sensors are there, right? And these sensors have to be monitored, right? And the data has to be monitored, and some of the data has to be stored here. And all these things can be managed by an interesting software called Node-RED. Node-RED is a very interesting software platform that you can make use of for home automation using edge computing. So somebody is interested in doing projects with Node-RED. Actually, it's a very interesting software. Okay. This is a very interesting software. It's very easy to learn also, Node-RED. You can install it on your computer, maybe on Raspberry Pi or whatever it is. And actually using that, you will be able to connect together the various sensors, the actuator, analyze the data, right? Make decisions. For all these things, you can make use of this Node-RED platform. It's very easy to use also. You can run it on your own browser, maybe your Firefox browser or Safari, Chrome browser or Outlook browser, whatever is Edge browser. In all those browsers, you can run this Node-RED, this particular platform for implementing edge computing in a smart home application, whatever it is. This is a very interesting idea. Use very powerful platform also. It's a very powerful platform. Those people who are interested in Node-RED, I think they can get quite a lot of very interesting introductory videos on Node-RED, how to use Node-RED on internet. It's a very important platform that you can make use, right? So here in the home application, what you are doing is we want to monitor and control the various home devices. You may be having refrigerators, microwave ovens, maybe the room temperature controllers are there. A lot of devices are there, especially in a smart home, right? You want to monitor the devices, you want to control the devices. For that, you are having a lot of sensors. Then the edge servers will be collecting the data from the sensors, and it will be analyzing the data. From that, it will be making certain decisions, right? And if a lot of long-term decisions have to be done, or long-term storage of the data has to be done, or else maybe if the whole house owner is at a very remote location, the various information or the data, the pictures, everything from the home has to be watched and analyzed by the person who is at a distant place. Then you'll have to connect to the gateway and the cloud data centers and all those things, right? So this is a very, the important thing is not to go into the technical details too much. It's not very important. See, we have to go into a general understanding is the most important thing. Technical details, any person can gather at any time. Once when you start doing something, you will be learning the technical aspects of the thing very easily. And these things are not very complicated also. Already you are having internet communication is there. Already you are having cloud services. You can subscribe to many of the cloud services free of charge. If the services required by you are not very high, Amazon and IBM and all those things are providing you free cloud services also. So very small tasks and all, you can make use of them, right? And then you are having tools like Node-RED that you can use for actually developing edge computing platforms and all those things. I'm not going into the details of the Node-RED and all, right? That you can see. And some of the advantages of the edge computing is given here, you see. One important thing is it reduces the latency that we have discussed earlier. So because a lot of processing is done at the source itself, at the edges itself. So the latency has been found to be decreased by even 99%, you see. Such a huge reduction in the delays and latencies can be achieved by making use of edge computing. That's a very large actually advantage that we are deriving from implementing edge computing in many of our requirements. And another, the bandwidth optimizers. You see, 60 to 70% reduction in bandwidth usage is achieved because you are not sending all the data. Only when it is extremely necessary, you are sending the data to the cloud data centers. Otherwise, you are doing all the processing at the edges itself. So the bandwidth utilization is very less. That means the reduction in bandwidth usage is very large. That means you have to spend less money on your internet connection, right? You are using less GB of internet you are using for this thing when you are having edge computing, right? And 30% reliability actually, it is increasing by around 30%. The edge computing systems are more reliable, right? And security also. Once when you are sending data through an internet, there is always a question of data privacy and security. For example, a patient's data is sent to a remote cloud server. You know, these data are all very are of a private nature, and nobody wants to disclose that data to people who are not intended to intercept that data, right? So privacy and security are very important. When you are sending only extremely necessary data to the internet, that means the security and privacy is better. So there is the survey show that 82% IT professionals cite data privacy and security as the primary reason for adopting edge computing, right? So privacy and security is increased. And again, real-time insights. That's a very, very important thing, right? What do you mean by real-time insights means? When you are analyzing the data at a remote server, that means you are making decision. The decision making is slower, right? But when the data analysis is done at the edges itself, you are having faster real-time decisions are there. And from the analysis, even the human persons who are at the edges, they can also get a lot of good insights about the working of the system, right? And again, the cost efficiency. There is a 50% cost reduction in data processing network bandwidth, because otherwise, for example, if it's a big company, if they are subscribing to some cloud service, they have to pay a lot of money to the cloud service provider, right? And if they are having their own edge computing platforms, actually the usage of the cloud service is very less. Through that, around 50% reduction in the cost reduction is achieved. Then the other thing is scalability is the scalability. Actually, we have talked about the scalability earlier, but scalability means here what we mean by scalability is you can create a lot of edge computing devices that are needed by you. That thing you cannot demand from a cloud service provider, right? Different paradigms of edge computing can be actually achieved and realized, set up, deployed at the edges itself. And offline operation. See, when you are using cloud service, you have to, it is online. You have to make use of internet, right? But when you are doing a lot of edge computing and all at the edges, you don't have to use the internet, right? The processing, the data collection, everything is done at the edges itself. So offline operation is another advantage. That is 76% of IoT developers prioritize offline operation. Online operation is actually problematic because if the internet connection is not good, and all online operations are going to be very difficult, right? And the latest trends in edge computing, if you go to that thing, see, now it is the age of artificial intelligence, machine learning, and all, right? So what we can do is at the edges itself, you can develop and you can maybe run a lot of AI machine learning algorithms. Especially you have something called tiny ML, tiny machine learning things, right? Those things can be even deployed on small microcontrollers and microcomputers like Raspberry Pi, maybe even on Arduino, something can be done. And maybe you can use FPGA boards to implement a lot of machine learning algorithms and all those things, right? So artificial intelligence, more real-time data processing, decision making, like that. And another thing is nowadays, this is today, now we have 5G system and we are planning to, it is proposed to move on to the 6G systems later on. And currently how we can make use of 5G system, how to integrate edge computing with the 5G systems. That is also a very important area of research. And how to manage the dynamic resource allocation between the edge computing and the cloud computing devices. We are having edge computing devices. We are having cloud computing devices. How to optimally manage the resources, the computing, everything between the edge devices and the cloud devices. That is also hybrid architectures. You can have a hybrid architecture which is having edge computing as well as cloud computing. So there are quite a lot of research works going in this area also. Not just research work, we can also do a lot of things as our undergraduate projects also. And another issue is about the security and privacy in edge computing systems and how to develop IoT systems, smart cities, and other things also. So like that, there are a lot of trends in edge computing that you can follow. And in industries also, how to do remote patient monitoring. Especially we are aware of the need for remote patient monitoring when this particular the COVID pandemic was on the rise. You know that actually the doctors, they could not reach to every place and the hospitals were also crowded. So a lot of patients have to be remotely monitored at their own homes. So remote monitoring, patient monitoring is a very, very important thing for which you can use this thing, edge computing, and also medical imaging analysis. See, medical images, X-rays, maybe scanned images and all. If you are sending all those things to a centralized cloud network, you know these images are of very large size, maybe some GBs. So if you can do that image analysis at the edge devices itself, so that's also another area. and maybe manufacturing in the industries, how to maintain the various equipments in the industry, how to maintain the quality control. Like that, you are having a lot of areas, new areas in the edge computing domain, where new systems are actually very important. And here actually I given an edge computing system in a 5G network. You see, this is the, see what is the difference between 5G and internet is. See, 5G is only a communication architecture that you are using to build the internet, right? Internet actually is having a lot of architecture. There is 4G is there in some places. They are even using 3G, right? And many other technology, fiber optic technology is there. And all these technologies are used to build the global network called internet, right? And nowadays, actually, a lot of networks are being transformed to the 5G architecture. And in the 5G architecture, you can see in a communication system, you are having base stations, right? Everywhere you are having base stations. And to the base stations are connected to various devices, IoT devices and all. They can all communicate with the base station, and through that to the whole internet. A lot of edge computing processing can be done here. Smart homes can be there, autonomous vehicles can be there, industrial systems can be there, right? And like that, you can have a lot of weather monitoring can be done. And these are all MEC multi-access edge servers. These are all edge servers. These will be doing a lot of processing of the data generated here. And only when these things have to be sent to a cloud network, they will be sent. Otherwise, a lot of processing will be done at the particular geographical locations where you are gathering the data. So there is a very important area of development in which we have to find out how edge computing can be very effectively implemented in 5G networks for smart home automation, maybe for a hospital, healthcare domain, maybe in industries, in vehicles, autonomous vehicles, and so on, energy systems. So that's all about this particular presentation. I suppose that you got a general idea of what actually this is all about. And if you are having some questions, maybe we can have a discussion on those things.
Yeah, thank you so much,
Actually,
Doctor, for this. Yeah.
Okay, I would like to hear the feedback from the audience also, whether they have understood something. My presentation was okay. Or if they are having some doubts and something, if something that I have explained is not very clear, please, you can. Okay, Mahmoud, please.
Yeah. Actually, my name is Basil, Doctor. You teach me in the
Thank
university.
you. Thank you so much for the presentation. It was very clear. I like the idea that you use pictures and try to give some real life examples. To be honest, once I joined this meeting, I was thinking, what is edge computing, and what is the difference between edge computing and the technology that we have nowadays that's related to cloud. So, alhamdulillah, I really got a lot of information from this presentation. Thank you so much for presenting this presentation to us. Thank you.
Thank you. Welcome, Mahmoud. Actually, it's very nice to hear your feedback. And actually, what I would suggest is people should come forward and try to do some projects, some experiments in edge computing. Especially, you can make use of Arduino and other microcontrollers. And maybe please try to study Node-RED. I think it's a very, very interesting platform. Just try to read and study about Node-RED, how we can use it for developing edge computing paradigms and all. Thank you.
I would just add, if you allow me, if you could tell us more resources that we can get if we want to have more information about this topic. Thank you.
Yes, there are quite a lot of textbooks available, and there are a lot of research journal articles also there. But I wouldn't suggest that you should go out and read the research journals. It would be rather better to go and read certain textbooks. And suppose if I can, I think I have connection with Basil. He's a student of mine. I will pass over to him certain textbooks in PDF format. Is it okay for you? Later on, maybe he will share it to all of you. Textbooks,
yeah, sure.
fundamental.
Sure.
Yeah, actually, Doctor, send everything to me, Doctor. Yeah, actually, Doctor, send everything to me, and I will direct it to the WhatsApp group, which is written here in the chat.
Okay.
Yeah, thank you. And also, Doctor, regarding this session, I have a question for you.
Okay, then.
Yeah, Doctor, is it costly to implement, like, for example, processors or PCs in each edge to make computations?
No, actually, a lot of computing devices are already available. Now, many people have their own computers, laptops, right? And it is not very costly to buy microcontrollers, Raspberry Pi, and all. They are all damn cheap now. So, based on your needs, actually, sometimes you may not be needing a very high an edge computing server with a very high computing power. Only when, and also the servers that you are using in cloud networks and all are very, very expensive compared to the edge servers. Edge servers are only addressing the needs of a very small geographical area where you are having some definite number of servers and actuators and all. It's not going to be very expensive. Cost effectiveness is one advantage of edge computing systems over the other things. You know, the servers in cloud networks and all are very, very big, huge ones with huge processing power. And they are all very expensive also, right?
Yeah.
Anybody else actually has to add something to the things that I have told? Maybe some of you might have already gone through and might have some ideas about edge computing. If they want to share something of their own, I would be very happy to learn from you people also. Quite a lot of very smart people here, I suppose. Anybody wants to add something to what I have been told here, or maybe something, it would be very welcome.
I'm more interested in this topic, but I'm kind of hesitant to ask because I think I'm the only one who's asking. But do you recommend any project that we can do at our houses that's not costly?
Yes, of course, we can actually do. If you can sit and discuss together, actually, once when we are implementing something, we have to first have an idea of what is our need. That is very important. Suppose if you want to have a home automation system, what are the particular devices that you are using in your house, and what are the different types of control that you want? First we should have a definite picture, a map on the needs that we are actually having. Based on that, we have to make the development. It's not a very we have to ultimately address the needs of our homes, our individual needs, the needs of our society. So this is one actually big challenge that we are facing in many countries. We are not at all thinking about the needs of our society. We have to look around and see what is the need, what does our society need, or what does our workplace need, or what does our home need, or what does the mazra or farm that we are having need. Identify the needs. And based on that need, we have to determine what are the different types of sensors, what are the different types of actuators and other devices that we'll be needing for addressing these needs. Then how to connect them? What are the different options for connecting and processing the data? Like that, step by step, we can go there. And then we can think about the software platforms that we can make use of it in doing the thing. Especially this Node-RED, actually, I think it's a very interesting thing, very easy to learn also. You can, for example, you can have an home automation system using Raspberry Pi, which is actually controlled by a Node-RED platform. That Node-RED you can run on your computer, or maybe you can run it on your Raspberry Pi. And to the Raspberry Pi, you can connect a lot of the sensors and the various devices in your home, control them. You can do like that.
Thank you so much.
You are from which university, Mahmoud?
I'm from Yambo Industrial College.
Yambo Industrial College, right? You are which department?
Electronics and Communication.
Okay, very nice meeting you. You're a student there, right? Or a teacher?
I have graduated.
Oh, okay.
So, Doctor, are you interested in conducting another session in this field, but maybe some other time?
Of course, I will be interested. Maybe we can do something more practical, down to earth. Maybe how we will, for example, we can have a session on how to use Node-RED in conjunction with maybe a Raspberry Pi in developing a home or a smart home system or something like that. We can think of. You come up with an idea, and I can give you a broad outline on how to go about it. Maybe, and if students are interested, we can actually make groups, project groups. Maybe we will be developing certain ideas. We can implement some projects. A lot of things can be done. And the most important thing is it is not just listening to a lecture. You will be learning only by doing things. The insights that you gain by doing something, it cannot be replaced by anything else. However smart a lecture of any person may be, that's not going to help you unless you're ready to do something of your own. Buy a Raspberry Pi, buy some sensors, see how you can interface the sensors to the Raspberry Pi. Then think how you can control a Raspberry Pi using a Node-RED software platform. When I speak all these things, actually, you are only getting some vague ideas. But when you start doing these things, you will understand, oh God, well, mashallah, all these things are very easy. We can all. That's all. That is how you develop your skills, right? Experiment with things.
Yeah. Is that it, Doctor? Is that it?
Yes, that's it.
Yeah. So thank you so much, Dr. Thafasalijyas, for conducting such an enriching session in an amazing way, as usual. And also, it was a wonderful opportunity in which we learned a lot. For me personally, I've never heard about this topic before. So this is why I enjoy learning something new. And it will definitely be not the last time for you to conduct other sessions, inshallah. So thank you so much, Doctor, for this session. وشكرا جزيلا لكم على حضوركم، يعطيكم ألف عافية على تواجدكم معنا، وأتمنى أن كنا عند حسن ظنكم وتطلعاتكم، وشكرا لكم.